Well, this video is for Math 63, and this is for the week 3 assignment on algebra and formulas. So we've got basically the first 3 sections of chapter 4 in the textbook that we're going to draw from here. So let's take a look at some of these problems. So problem 2 has the formula in the problem. M is equal to y2 minus y1 over x2 minus x1. Now don't be afraid of these subscripts. It's just another way of naming a variable. Sometimes in mathematics, instead of calling things a, b, and c, we can call them a1, a2, and a3. And that can be helpful sometimes, especially if you have more variables than you do letters in the alphabet. I had a friend who had to write a computer program for school scheduling, and he told me how he had thousands of variables. And so in that situation, a lot of times people number their variables instead of using a different letter. Okay, and what's going on here is that you've got 2 different x and y values. So let's see here. x1 is 4, and y1 is 2. And then x2 is 9, and y2 is 10, I believe. Yeah, okay. So all we really have to do here is just plug these into the formula. So y2 is 10, y1 is 2. There we go. And then x2 is 9, and x1 is 4. So this is 8 on the top, 5 on the bottom. You can leave it like that, call it 8/5. If you want to go ahead and divide 8 divided by 5, then that should give you 1.6. Okay, let's see here. Problem 4, and the rest of these problems as well, the formulas for the rest of the problems are back in the chapter. So let's see here. For problem 4, the formula we need, VO2, the volume of oxygen, is 0.2 S plus 0.9 S times G plus 3.5. So the S is the speed and the G is the grade of the hill as a decimal. Okay? All right, so let's see here. So the speed that we've got looks like it is 3 miles per hour. 0.9, and then 3 miles per hour. And the grade is 10%, so we need to express that as a decimal, and so we'll call that 0.1. And then we've got that 3.5 on the end here. Okay, so we don't really need a calculator all that much for this problem, but we'll use it anyway here. This one's going to be 0.6. Let's see here. What is that going to be? It looks like 0.27. I'll check that out. 0.9 times 3 times 0.1, 0.27. And then plus 3.5. And so we'll add these all together, and we should get 4.37. See here, 4.1, 4.37, looks good. All right, now we get the temperature problems. Let's see here, in problem 6, convert 98.6 degrees Fahrenheit to Celsius. And so the formula we need is that the Celsius temperature is 5/9 F minus 32. Now we don't really have to worry too much about what I'm going to talk about right now, but I just find it interesting. Where this formula comes from is how the different scales are set up. Okay, so let's see here. Let's call this one Celsius and this one Fahrenheit. In Fahrenheit, freezing is 32 degrees. In Celsius, it's 0. That's why we subtract the 32. The 5/9 or 9/5 that you see in that formula has to do with the fact that the gradations on the Fahrenheit Fahrenheit scale, 1 degree Fahrenheit, those are much finer than the degrees on the Celsius scale. In fact, they're 5/9 of a Celsius degree. Okay? So the Celsius degrees are a little bit wider than the Fahrenheit degrees are, and that's what the 9/5 and 5/9 do. Okay, so let's see. What are we doing? We're converting 98.6 normal body temperature in here, so 5/9, 98.6 minus 32. Okay, so let's see what we get here. 98.6 minus 32, so that's going to be 66.6, and then we'll multiply that by 5/9, and what does that give us? 37 degrees Celsius. So that's normal body temperature. All right, let's see what else we've got here. Problem 8. Frost damage to most plants that occurs at temperatures of 28 degrees Fahrenheit or lower. Okay. And what is this temperature on the Kelvin scale? All right, well, the Kelvin formula here is 5/9 F minus 32 and then plus 273.15. So the Kelvin scale is very similar to the Celsius scale, except that the freezing point of water in Kelvin is 273.15, whereas in Celsius it's 0 degrees. So Kelvin and Celsius, their degrees are the same width. Okay, so notice, we're going Kelvin to Fahrenheit here. But between Kelvin and Celsius, their degrees are the same size, but their freezing point for water is different. All right, well, let's just work with this one then. So this 28 minus 32, so that's going to give us a negative value here, 5/9 times -4 plus 273.15. Okay, so let's see here. -4 times 5/9, and then add on 273.15, and we can round this off here. It's going to be 270, we'll call it 0.93 degrees Kelvin, and so that's going to be just a little bit below the freezing point. That's what the problem is all about, is that the plants are damaged when the temperature is just below freezing. Okay, or colder. Let's look at a couple more of these temperature problems. Let's just look at number 10 here. We've got a tungsten light bulb which operates at 2900 degrees Kelvin. And let's see here. What is it in Fahrenheit and what is it in Celsius? I'm going to do the Celsius first because it's so simple. K minus 273.15. So we do 2900 minus 273.15, 26.85. 85 degrees. Okay, that's a very, very hot temperature. Let's see here. What would that be in Fahrenheit? Let's see. Well, let's take our, let's see here. That's going to be 9, we need to take the 9/5 times the Celsius and then add on 32 degrees. Okay, so we're going to do 9/5 times 26.85 and then add on 32. So times 9/5 and then add on 32. So this is going to be over 4,000 degrees, almost 5,000 degrees Fahrenheit. Okay. So like I said, that is a very hot temperature. Okay. All right, so that's it for section 4.1. We'll see another formula in section 4.3, but in 4.2 we're going to talk about solving algebraic equations. Now, algebra is a pretty old field of knowledge. Okay, Chinese mathematicians had a series of algebraic techniques that they used to solve problems. Some of them were sort of centered around a guess and check process that became progressively more complex depending on how hard the problem was. Indian and Arab mathematicians used techniques of algebra to solve problems. In fact, the word algebra comes from the Arabic language, Algebra, okay, which has to do with this balancing and trading back and forth between the sides in an equation. And that is what algebra is. Okay? So let's take a look at some sample equations here. Problem 14, these are on page 152. So in problem 14, we've got -4 plus y equals -9. So the idea here is that that equals sign says that these two sides of this equation are in balance with each other. This is a two-beam balance. Okay, and this says that -4 plus y and -9 are the same thing. Okay, so the idea in solving this equation is that we want to get this variable y by itself. Our goal is down here to have y equals something, and then that'll be our answer. We'll know what the value of y is. So we want to counteract anything that's over here with the y. And so what we're going to do is we're going to add 4 to this side, but that would make this side heavier. So we're going to add 4 to both sides. Add 4 here, add 4 here. That means over here we just have y. And over here, we're going to have -9 plus 4, which is -5. Okay? And I encourage you to use your calculators on this. So every equation has two sides, and so just like this, like I was saying, this double beam balance, and so anytime we do something to one side, we have to do it to the other. That leaves you with y on this side, -5 on this side, and that keeps everything in balance. Okay? All right, so let's look at a couple more of these type. Let's see here. Problem 16, we've got x plus 2½ equals 3 1/3. Right? So again, we're running into fractions, and I encourage you to think about this and try to solve it on your own, but you've got a calculator, so in the end, go ahead and use it, or do it yourself and check yourself on the calculator. Okay? Maybe I think I'll do that. Okay, so I'm going to do this myself. For something this simple, I'm going to make these improper fractions. This is 10 over 3 minus 5 over 2. And then I'll make a common denominator here and here. So this is 20 over 6 minus 15 over 6 equals 5 over 6. And there we go. We're all done. I mean, I don't really feel the great need to check my answer, but you never know. Maybe I made a mistake. Oh, that's what this calculator is terrible at doing mixed numbers. 3 plus 1/3 minus 2½ Yeah, 5/6. Okay. Let's see, what else here? So in this one, so notice when we had something that was being subtracted, like that first problem, we had -4 plus y equals -9. So the 4 was being subtracted, or it was a -4, so we counteracted it by doing the opposite. Here, the 2.5 was being added to the x. It was a positive 2.5, so we did the opposite. We subtracted. Here, this -3 is getting multiplied by the a, and so to do the opposite there, we have to divide by -3. -3 over -3 makes 1. Those cancel each other out. Over here, we do the same thing on the other side. -30 divided by -3 is 10. Okay, so the goal here is always to end up with 1x or 1a equal to some number. Okay. All right, let's see here. Problem 20. X over 3 equals -1/2. So x divided by 3 is -1/2. So again, notice the fraction bar means divided by, so we want to do the opposite. We want to multiply on both sides by 3. You can think of it as 3 over 1 if you want to. Either way, those 3's cancel each other out, and we're left with just a 1x. That's what we want. Here, we just have to multiply these two fractions. It's pretty straightforward, -3 over 2, or if you like decimals, -1.5. Okay, problem 22. We've got 2/7 x equals -6. So here's the thing here. I know a lot of students in Math 70 and Math 95 and the 100 level courses too. If you're working with a calculator, you can think of this as 2/7 times x. And so you can just divide on both sides by 2/7. Now, if you're going to do this on a calculator, you should be careful, and probably you might need to put your 2/7 into parentheses. Okay? So that will cancel these out, and over here, what are we going to get? We're going to get -21, it looks like. Okay? Now the way I do this problem, since I went to school before we used calculators very much, I mean, I did use a calculator in high school, but when I was learning fractions, I just learned to multiply by the reciprocal. See, the 7's cancel, the 2's cancel, there's your x. Over here, that's going to give us our -21. Okay? So this works. You can do this. If you do this on a calculator, again, be careful with the parentheses. But this, like, how do you calculate -6 divided by 2/7 is by multiplying -6 times 7 over 2. Okay? So that's the reason why I just skip this step and just go ahead and multiply by 7 over 2. All right, let's keep going with these. All right, now in this section, the next section here, starting with problem 23, I'll do 24 as an example. We've got problems that need 2 steps. Okay, so you can see that we've got that +2 hanging around there. So let's get rid of this so that we get the thing that has the y in it by itself. Okay, so we'll subtract 2 on both sides. That'll leave us with -3y here and -15 over here. And then we'll divide on both sides by -3. Y equals +5. There we go. Okay. Problem, let's see here. Let's do 28. Problem 28, -10 equals 2x minus 5. All right. So again, we want to cancel out this 5, so we'll add 5 to both sides. That'll leave a 2x here and a negative 5 over there. And then we'll divide on both sides by 2. And so over here, negative 5 over 2, or if you like decimals, you can call it negative 2.5. Okay, let's see here. Well, let's go ahead. Let's look at problem 30. Problem 30, we've got 3/5 x minus a half equals a tenth. Okay? So we're going to add a half to both sides. So that'll leave us with the 3/5 x. And over here, right, this is 1/10, this is 5/10. That'll give us 6/10, which is actually 3/5. So this says 3/5 x equals 3/5. Well, the answer here is 1, right? Because 3/5 times 1 is 3/5. So, but to get the solution, we would want to divide on both sides by 3/5. And 3/5 divided by 3/5 is 1. And again, the other thing you can do here is to multiply on both sides by the reciprocal. 5 over 3, and these all cancel out and leave us with 1. Same exact thing. All right, let's look at problem 32. Problem 32, a little bit tricky. We've got negative x minus 5 equals negative 2. Okay, well, what's over here with the x is the negative 5. So let's cancel that out. That'll leave us with negative x. And over here we'll have positive 3. Now, to get rid of this negative sign, you can multiply or divide by negative 1. Right? This negative sign in front of the x is like a negative 1. And so to get rid of it, we want to divide on both sides by negative 1. And so if negative x is 3, then x is negative 3. All right, the last couple problems in this section have variables on both sides of the equation. Problems 33 and 34. So problem 34, we've got negative 2y minus 7. And on the other side, 3y plus 13. Okay, so the trick here is we want to collect all the constant terms, all the numbers on one side and all the variables on the other side. It doesn't matter which side you choose. I'll move this 7 to be over here with the 13. That'll cancel this out, leave me with negative 2y, and then on the other side, now I'll have 3y plus 20. Okay, now I want to move this 3y over to be with that negative 2y. So this is a positive 3y. So to move it, oops, I have to subtract 3y on both sides. So these cancel out, leave us with 20. Over here, negative 2 and negative 3 make negative 5. And then our last step, divide on both sides by negative 5. And so we get y equal to negative 4. All right, so that's it for section 4.2. And then the last section in this week's assignment is section 4.3, where we've got another formula. So here we've just got a single formula, C1 V1 equals C2 V2. Okay, so the idea here is that we want to know how to prepare a formula. Okay, so problem 36 says prepare two 40% solution using a 40% stock solution. Okay. So the trick here then is going to tell us how many milliliters of the stock solution we need, and then we're going to add water to it to dilute it down to the 20% that we want. Okay? So the way to calculate how many milliliters we're going to need is to take C1, see here's these subscripts again. We've got a concentration and a volume here, and a concentration and a volume here. The numbers, what they're saying is make sure they match up. This concentration matches up with this volume. This concentration matches up with the volume that we're going to try to find. Okay? So we can use a variable to represent that. Let's see here. All right, so 200 times 20 equals, well, let's see, let's put them in the right order. Okay, the concentration is 20%, the volume is 200 milliliters, and then on the other side, the concentration is 40, and we're going to solve for the volume. Okay, all right, so 20 times 200 is going to be 4,000 equals 40V, and so to solve this, we'll divide on both sides by 40, and that should be 100. So we need 100 milliliters of 40% stock, and then we're going to add 100 milliliters of water. Okay. Right? Because we start with 100 milliliters of 40% stock. We need 200 milliliters, so that just means the rest of it's going to be water. Okay? And to get this answer, all you have to do is this volume minus this volume gives you how much water to add. Okay? All right. Let's look at another one of these. Problem 38. 500 milliliters, 25% solution. And using a 50% stock solution. Okay, so concentration 1 is 25, volume 1 is 500, concentration 2 is 50, and we're going to solve for that volume. Okay. Oh, when it comes to the concentration, you know, you might question yourself, oh, do I want to use the percentage number or do I want to represent it as a decimal? And the answer is it doesn't make any difference, but if you use 20 here, you have to use 40 here. If you use 0.20 here, you have to use 0.40 here. So either way it'll work. The key is to be consistent. All right? All right, let's see here. So 25 times 500, that's going to be 125. So 12,500 equals 50V. And then we'll divide on both sides by 50. And so this will be 250 equals V. So it's 250 milliliters of 50% stock. And then how much water do we need? We need another 250 milliliters of water. So notice that when you add the same amount of water to what you've got, it cuts the concentration in half. Now, hopefully we'll see some problems that are a little bit more interesting than that, but let's see here. So, problem 40, this is a little bit different. All right, so we want 400 milliliters of 3% solution using 15% stock solution. Okay, so concentration 1 is 3, volume 1 is 400, concentration 2 is 15, and we're going to solve for that volume. Okay, so 3 times 400 is 1,200, and then we'll divide on both sides by 15. What is that going to be? It looks like it's going to come out to be 80. Let's see if that's right. 1200 divided by 15, 80. There we go. Those cancels. V is 80. So we need 80 milliliters. 80 milliliters of 15% stock solution. And now, how many milliliters of water do we need? We're going to need considerably more in this situation, 320 milliliters of water. So we'll have a total of 400 milliliters. And notice, so here, when we added the same amount of water, we cut the concentration in half. So notice that half of 15 is 7.5. We're going even lower than that. That's why we need so much water in problem 40. Okay, let's see here. Oh, so that's the last one in that section in 4.3 for these concentration and volume problems. You will definitely see these when we take the midterm in a couple of weeks. I'll talk more about that as we get closer to it. But that's it for this week's assignment. So, as always, if you have any questions about it, please let me know. Thank you.